Hello again. You may remember in the previous video I created this isometric block. The intention was to create a game or create an application with a set of isometric blocks, which is something I haven't done before. And I ended that video with a stack of blocks like this one. So when I actually come to program this, I won't draw, I'll be drawing the whole block, but I won't align them by the block. I'll be aligning them only by the top face. To give you an idea, this is the top face that I would be aligning by. So to move across the row, I would go to the right and downwards like here, and then to start a new row I would go left from the original point and then move downwards like this, and then continue on right and down like that. So to show you that better, here's a little video. From the origin, each block moves 16 across and 8 down for the whole row, as you can see here, and then to start a new row it goes back 16 and 8 down before continuing 16 across and 8 down, and that's repeated for each and every row, as you can see in the video there. And that's what I intend to do with the program that I'm going to write, specifically in a function that's going to align the grid in the same way that you saw in the animation. But first, if you're interested in how I write my classic games and other projects, visit my public GitHub repository, this one here, Arbian Public, and take a look at how to write a pixel engine down here. And here you'll find a guide for creating a wrapper class for the OpenGL GLFW library, pretty much what I do, the one that I use myself now. If you want to play around with this code yourself without going through this guide, then make a copy of the wrapper here, this one, B, and a copy of the template, C, here. And you'll probably notice that this template is will become familiar as we carry on. So with that in mind, we'll move on to the next part. The first thing that I need to do is convert the brick PNG into something that's easier to store and easier to manipulate in my program. So what I need to do is run a little program I previously wrote to convert the PNG file into two arrays, one which is used for the image and the other one for the colours in that image. And then once I've done that, I'm going to copy the output and put that into my template for use later on. So let's do that now. And I know the path anyway, so let's put that in. And you'll probably see from the output that this will create two arrays. The first one being the image here, and the second one being the colours that exist within that image. And this is just so I can make a more compressed, smaller format for the image when I store it within my program. So I'll just drop this down here, and for now I'll just put that into comments for use later on. And there we go, we're ready. If you look here, you'll probably recognise this template is very similar to the one that was on GitHub. So this should be quite easy to follow if you take a look at that first. So let's start by trying to get this image onto the screen first of all, before we start messing around with the isometric tile layout. So to do that, I'm going to need a function in my own header, or in my own GLFW wrapper. So I need to open that so I can show you the function. And should be one of my recent files here. And there you are. Well, you can see that I was looking at it recently. So here's the function that's going to be used to put the image onto the screen, which is just two for loops going through the picture array and then converting the colours using a given palette, which is here. So that'll make more sense as I'm going along. So the first thing we want to do is we want to make some containers for the data here and for the palette data that's underneath that. So I'm just going to move that down here. So let's start now. So a standard vector, I think. And we'll call that my pal. like so. And then the other one, the other container, if you I'll get to that in a second, sorry. There's actually, let's make that, let's initialize the data for this one now. So that would be this data here. And then we can just have that in place. Just tidy it up a little bit. And now for the image itself, I have a struct called canvas, which if you look in my GitHub repo, so I think I've called it surface, which is a name from when I used to use SDL. So, but for this this particular instance, I call this object canvas. So let's make one now. Note that it's a uint 8t. So 1 byte, which is quite small, and we will call that my tile. And to initialize this, to add the data to it, then we'll create a function to do that. So we can probably do that now actually. So that's the canvas, and then let's create a small function to do that. Let's call it init tile. And then we'll take that tile. And now I've got some methods that you associate with this and some variables. So the prime is to clear. I should show you here. This is the screen. The screen itself is a canvas, so screen prime here just clears everything to black. So for this one, we want to define the frame, which is the size. And the particular brick is 32 by 32 pixels, and because it's only a single tile going in the, it doesn't matter whether it went in X or Y direction. We only need to be 1 of 1 here, and you can see that it's actually defaulted to that anyway, so I could leave that out like so. And then we want to put in the tile size. These are kind of used later on, so 32 by 32 is 1024 equals 1024. And then we have the data itself, which is B. And now we can copy the data from here. Let's put that up here. Ah. Yeah, I think that's right. Ah, yes, I've made a mistake there, sorry. You have to do a new event IT, new array. That should do. So there we have the, so now we have the palette here, and we have the tile initial, well, we have the tile here but initialized here. So all we need to do is draw that to screen. So there's under the screen, so this is a one-time initialization, so we'll do the brick first. So we just do init tile, sorry, init tile there to initialize the graphic, and then under where we paint the screen black, we will put in our copy command, which is this one here. So swap byte canvas. Swap byte canvas. And it's expecting a certain type. So P or the template I have for P is similar to a pair. So you can have two variables and you can define the type when you create it. So that's just something that I use with my own operators, just for convenience. So I'm just going to, I think the first one is, in terms of the tile, is its position, so 0, 0. And then the second one should be the width and height, so 32 by 32. And then the last one is where I'm pasting it to. So the canvas I'm going to paste it to is the screen. So for argument's sake, we'll just do 64, 64. And then the next thing we need to do is the reference to the tile itself, which we call my tile. So let's do that here. And then we want to do the screen here, so and screen should do that. I know it's a bit overcomplicated really. And then we want to reference the palette. Have I done this right? Let's just check that. No, sorry. Lowercase. And then let me just check this. I think I just need to give the data. Let's try. And that should be enough to put a block on the screen. So let's compile that. No, we made a mistake there. Oh, used uppercase, sorry. Let's do that again. Hopefully this time it should get compiled. Okay, and then let's run this. So I'd already called this file isometric. As you can see at the top of the screen there. Pixie, and then there we have our brick. And that's what we were expecting, so that's good. In terms of the size of the screen, let's change that here now as well. So let's go for a classic kind of screen size, which is 256 by 192, which I think was the spectrum resolution. So we want to make this 1024. My quick maths is not so good, so I'm just going to start the calculator. And 4 times 192. I'm sure people can do that off the top of their head. 766. And let's run that again. And hopefully we'll get a larger resolution size this time. There you go. So now you can see quite a large brick in that sort of smaller resolution. Let's close that. Move this down. And plan on how we're going to tile this onto the screen. So before we write this function, we're probably going to need some constants to work with. So we know our map is roughly going to be 8 by 8, so we'll start with that. We'll define a couple of things here. We'll define a world X as 8 and a world Y. Not that. As 8, And then we'll want some constants, so let's move that down. And we don't need large numbers for these, so I'll keep them as units. 8, that is. And then we will need a tile width. And so this is going to be the space between tiles as they move across the screen. So the tile width is 16, as we saw before. And the tile height is 8. So we move down 8 and we move 16 across as we place the tiles. And the other thing we need, I think we're going to need a map. So we're going to need an 8x8 map for each level that we draw these bricks to. So with that in mind, we'll probably just stick with 3 levels for now, because I think it'd probably go off the screen if it was any more than that. So we'll create a world height of 3. And then those are the constants that we'll use when we come to write the function. And the other thing maybe we should create now is the map itself that we're going to use, because that will probably be part of the loop as we go through placing the tiles. So if we get that ready now, then it'll save us some time later on. And we're going to need a multi-dimensional array for this. So let's do an array of an array. Let's spell it correctly first. And that doesn't need to be large either. I think we've got 1 tile, so it's not going to make a big difference. And we want that size to be 64, which is 8x8. And then we want to do that 3 times. And to keep in with the naming convention here, we'll just call this my map. Very imaginative, I know. And then I think we'll probably need something to initialize this map. Let me minimize that for a second. So we have an edit tile, so let's have an edit map. And let's think now. We should probably have the map in here. My map. And then we'll populate that in a second. I just realised I hadn't put a standard there. I really need to add I need to include array, I think. I think I include vector but not array in my header. And then we'll add some content here. Let's just put this down for a second. This will be the top, this will be the bottom floor. All tiled. And the next 2 floors will be empty until we know that the bottom floor works okay. Okay, and then we'll edit that here. And let's make sure that this can compile before we go any further. Looking okay so far. Yeah, that compiles. So let's start the function. Okay, let's create the function here. We don't need any return from it, so we'll call it display map until I can think of a better name. And within that we want to have 3 loops, so we'll want to loop on each level, so 0 to 2 or 1 to 3, and then we'll want to loop for each of the rows and columns for the map, and then use that not only to find what kind of tile is in the map, but also to place the tile in the correct position on the screen. So let's create the 3 for loops first, which don't really need to be large. Yeah. The first one being levels, we'll do that. And you may remember we created the world height, so we'll put that in here. And that's our first loop. So let's copy this. Let's copy this for the next 2 loops as well. So for this one, this is y, and y is less than the world y. So this is the map we're drawing, and then y increases, and then we'll repeat the same thing for x. X less than the world x, and there's our 3 loops. So that should be enough to cycle through the map at each level. So what we want to do is that where we find a value greater than 0, we want to draw a tile of whatever particular type. So 0 is where there's no tile, and then 1 onwards is where a tile would exist. So let's do that now. I'll come back and make this a bit more flexible, but for now we'll just use my map. So we want the level, and then we want a value, an x and y value. Do that correctly. Yeah. And then we want a value of y times the width. So that's the width of the world plus the x value. And that will give us the coordinate. So, and if that's greater than 0, this is where we will draw tile. So draw a tile here. We'll need a value for that tile, so let's do that up here. It's not going to be larger than 256 at any time, so we'll leave that there, and then we'll keep the value here for the tile that's going to be drawn. So t will equal my map actually exactly the same. So we'll just copy that. And there we are. So that will be the tile value for that position. One thing we want to do though is side, that's okay. So we need to figure out the drawing position now. So in the while loop, actually, let's just create some variables for this. So we want a starting position. And we'll probably want some other things, but then we'll start with that. And then we'll copy that for now, because we want to change this one. And we will also create positions for the tiles, so row X and a row Y. Okay, and then here in the Y, we shall set those values. So this is only as we iterate through Y. So it makes more sense if I think about X here. So this is where we'll do the, in the X-axis is where we'll do the 16 and the 8, so down by 8. Across by 16. Here we will move left and down. So for each of those rows, each time we start a new one, we'll move down. So Y and here we're moving down, so Y, that there we're moving left, but here we're moving down. Y times tile height. So and then we need to move that starting point for each level. So that perhaps should happen here after in the L. Well, I was going to say 16, but I think we could just use tile for that. We might have to change that at some point. That's the world Y and the world X. No red. Oh, because of lowercase. Okay, change that, and now we can draw. So we'll just copy this here. And put our drawing function here. We'll comment that out for now. And now let's figure this out here. So I don't want to use the one I'd rather have that as an argument here, so we'll create something new. So we'll have a canvas of the same type as a pointer. We'll just call that tile. So let's change that first. Screen can stay as it is. And this data here maybe we should change as well. So In that case, that will be a vector. Sorry, standard vector. That's 32. We'll call it POW. Point it to POW. And then we can just change that to POW data. That's a bit better. We should probably do something with map as well, but I'll leave that for now. That wasn't start getting too complex. Okay, so let's do the drawing here. So 0 is always the starting point, but for the y-axis that might not always be true. So that will be based on the size of the tile. So here, because tile value starts from 1, I will need to take 1 off. And then times that. Yes, by the tile height. What I didn't mention before is that there are a couple of other variables that are created when you create a canvas, and depending on how you specify the tile size in the first arguments, then these are created as height and width for each of the tiles that exist in the canvas. So just in this case, TH and TW. So I can use them here as well. So that would be tile width, I think, and tile height. And here, this is where we put our row X and row Y. These are the drawing positions that we've changed. And I think that might be it. I'll need to compile and test that in a second. So here, let's call our new function with the correct arguments. So we'll say half of 192, so 96. We'll leave that 64. The tile is my tile, so and my tile, and the vector is my POW. Not literally. Okay, let's test that out. Wait for that to compile and see what result we have. Isometric. Oh, there we are. So we have our bottom or our base isometric tiles lined up. So let's move that across by about 16. I think it needs to come across by another tile. And move that up a little bit more as well. So do that first. So when we're placing this, we should place it at let's go across 112. I'm going to take 16 off of this as well. 48 should be okay. And let's add some extra levels here. So let's go to the map. Let's try making a hole in the middle or something, just to make sure this is working. So that should be interesting. Let's try that. I should compile a bit faster, but there we are. There we are, we see the hole in the middle now, that's good. Okay, that looks a bit more like we're aiming towards. So let's add another level. Let's add some detail on the next level. Let's just do 4 corners here. Maybe we'll do like yeah, enclosed corners. And on the outside of this hole, let's just do a couple of tiles. Let's just try that for now. Yeah, sorry for the compiling wait. This doesn't normally take this long. Oh, here you go. So that's probably needs a little bit of light difference in sort of tile shade here, but pretty much what we're looking for. So let's come out as expected. Let's get rid of the near one. And then let's add an extra on each of the on the next level as well. Not too much. And we had one here, didn't we? So let's do one here. Okay. Right, let's try that. There you go. So that's they stack correctly. Probably could do with some different tiles to put into the map, but I think that's pretty much what I was hoping to achieve with this. So I'm going to call it there. I'll keep that function for later, and if I use it again, then I'll mention it in another video. So thank you very much for watching.